In this segment, we're looking at systems of linear equations in two variables. So that'd be a system like this down here, this 3x plus 2y equals 6, and 2x minus y equals 5. So just plain x's and y's in our equations. A solution to such a system is going to be an ordered pair that works or satisfies both of those equations. So if this is my system, is 4, negative 3 a solution? Well, in an ordered pair, the first numbers are x, the second ones are y, so we plug them in and see what happens. When I do it in the first equation, it seems to be okay. 3 times 4 is 12, 2 times negative 3 is minus 6, so 12 minus 6, yeah, that's 6, okay. But when I take it and I plug it in the second equation, we end up with 8 plus 3, which is 11. That's not 5. So because it doesn't work in the second equation, we have to say it's not a solution to the entire system. Okay, so what is the system's solution? How do we get that? We have several ways of finding those solutions. We can graph, we can use substitution, or we can use the addition elimination method. Now graphing is going to be a little bit easier because we have graphing calculators. When we graph systems with linear equations in these two variables, we always get lines, and those lines might intersect, be parallel, or actually be the same line. If they intersect, that means there's one point on both that they share, so there's one solution. We call that an independent, consistent system. If they're parallel, then there's no points that they will ever have in common, so there's a no solution. That's also considered independent, but it's called an inconsistent system. And the last case is a same line. So even though the equations might initially look a little bit different, when you actually graph them, you realize, hey, they're really the same line, so there's an infinite number of ordered pairs in common, or infinite solutions. This one's called a dependent system, but it's again consistent because we did get a solution. Okay, now the substitution, addition, elimination method, or algebraic methods, we're going to look at in another segment. Let's take a look at the graphing. If I want to solve by graphing, what I'm probably going to do is make myself some tables here. So x plus y equals 1, I'm going to solve for y and get y equals 1 minus x. No restrictions or fractions or anything weird, so I'm going to use 0, 1, and 2 and plug those in and get my ordered pairs. So I've graphed this blue line for the first equation. Second equation, same thing. Solve for y, pick some x's and plug them in and get some answers for y. Then we're going to graph this green line here using those ordered pairs. Now I would suggest using grid paper if you're going to do this by hand, because you want to be able to see clearly what that intersection point is. Looks like 3, negative 2. But to be sure, I'm going to take 3 plus negative 2, that's 1, yep, that works. 3 times 3 is 9, minus 2 is 7. It works there as well. Now, I did it by hand, but sometimes we don't get nice intersection points, so we actually want to be able to use our calculators as well. I'm still going to have to solve both of my equations for y, so I've gone ahead and I've put them in here. I'm going to go ahead and start with a standard window, so zoom 6, and there we see the two equations graphed and we see an intersection point. To find that, I use the calculate menu, so second trace, and we go down to number 5, intersect, and it asks me, is this your first curve? And I can see, yes, that's one of my curves. Is that my second curve? Yes, and I hit enter. A little too quick. Third question is guess. So I move close to where they cross, and there it tells me 3, negative 2 again.